Here we're given a function defined by a map, and what we want to do is find the inverse function. First, we notice that the function is in fact one-to-one because each output is the result of only a single input. To find the inverse of the function, we recognize that for the function, the input is location and the output is rainfall. Therefore, for the inverse, the input is going to be rainfall and the output is going to be location. So I write rainfall for my input and then location for my output. So what location has rainfall of 460 inches? That's going to be the Hawaiian location. Don't expect me to pronounce that. For the rainfall 202.01 inches, the location is Liberia. 196.46 inches, the location is the American Samoa. For rainfall 191.02 inches, the location is Burma. And finally, for 182.87 inches, the location is New Guinea. Now what we want to do is find the domain and range of the inverse function. The domain is going to be the set of all rainfalls. The range is going to be the set of all locations. So when I write the domain of the inverse, it's going to be 460 inches, 202.01, 196.46, 191.02, and 182.87. Notice that the domain of the inverse is the same as the range of the original function. Now to write the range of the inverse, that's going to be Hawaii, I'm going to be really lazy here, Liberia, the American Samoa, Burma, and New Guinea. Notice that the range of the inverse is the same as the domain of the original function. Remember, we also define functions using ordered pairs x comma y, where the set of all x represented the inputs to the function and the set of all y represented the outputs of the function. So to find the inverse when a function is defined by a set of ordered pairs, all we need to do is interchange the x's and the y's. For example, consider the function defined as shown. If we want to find the inverse of this function, we recognize the following. For the ordered pair, -3, 5, the input to the function is -3, the output is 5. Therefore, in the inverse, the input is going to be 5 and the output is -3. The input here is -2, the output is 9. So in the in the inverse, the input is 9 and the output is -2. We continue in this fashion, filling out the rest of the ordered pairs. Now what we want to do is determine the domain and range of the inverse. The domain of the inverse is going to be the set of all inputs, which is 5, 9, 2, 11, and -5. The range is the set of all outputs, which is going to be -3, -2, -1, 0, and 1.